All right, we got it. Okay, so we're going to talk today about what a power series is. We've actually been dealing with this because Taylor and McLaurin are power series. Eventually, we called them polynomials the last few days, but we're eventually going to see them as a series. Today we're going to kind of just look at what the definition is, and then we're going to talk about this thing called the interval of convergence, and that's kind of what this first section is, and then there's another section on power series, okay, and then there's one on Taylor and McLaurin, and that's pretty much it with what we got to do in Chapter 9. Then we'll finally be out of Chapter 9. Alright, do you have to fill in or no? Are those filled in? They're filled in. You have to do this part? Okay, so get that part in green and then we'll talk about it. Okay, so a power series is basically set up as a series or a polynomial that we add together where they have exponents. So this one basically up here looks almost like a Maclaurin, except there's no factorials, right? But a factorial would just be a coefficient. More generally, if we've centered around something, it's more like the Taylor format. And again, we don't have little factorial on a general power series. Okay? So, what we're going to do with the power series is we're going to do this thing called find the interval of convergence, because a power series can converge, okay, which is what we spent the first part of the chapter doing. So we're going to do that, to find the interval of convergence, we have to do two things. First of all, we have to use the ratio test to find out when the ratio is less than 1, and that's just the rule, it has to be less than 1, okay? And then we're going to check the endpoints, okay, and that's going to make more sense when we actually do it, okay? We have to actually check the endpoints, and I should have probably written in there for convergence. So you might want to add for convergence in there. So check the endpoints for convergence. All right. 2 examples. Did I leave lots of space? Good. Both of them take like 2 slides. Okay? So just so you know what you have to do for space. Because we've got to do 2 things. First, we have to find the interval using the ratio test, and then we have to check it to see if it converges on that ratio. Okay? So, first step is use the ratio test, okay, to find the interval. So I'm going to go ahead and put this thing into the ratio test. Remember, ratio test is where we put in n plus 1. So we do the limit as n approaches infinity of the absolute value of x to the n plus 1 over the square root of n plus 1, and then we're supposed to divide by the original or multiply by its reciprocal. And after you've written that down, you're going to want to get out your chart, your red and green chart, right? With the series, all the series in it. All the converges, diverges chart, that one. Get that out. Yeah, get out the flow chart. Yeah, your Christmas present. We're going to need it today, okay? Okay, so, notice the ratio and root test are on it, right? They're down at the bottom half somewhere. They're both down there. Okay, so what I'm going to do is we're going to simplify it. Remember we learned, and we could probably shortcut this a little bit. Hopefully you've had some practice. What happens with this and this? What's that going to reduce to? Just x to the first, right? The n's are going to end up canceling. So that's going to make that one go away completely. So what I'm really down to is the limit as n approaches infinity of x times the square root of n over the square root of n plus 1. So I want you to think about this a little bit. If I'm looking at the limit as n approaches infinity, does x have anything to do with that? Am I plugging this in for the x? No, it says I'm plugging it in for the n. So I'm going to show you another way that this could be written, okay? So I could take this and peel it off and put it out front. So I'm going to take and put the absolute value of x out front. And now I've got the limit as n approaches infinity of the square root of n over the square root of n plus 1. All right. What does this limit equal? 1, right? Because those are the same exponent, so we just look at the number in front. So that's really 1 times 1. Okay. Sometimes we get another coefficient off of that. All right, so that's why we have to look at that. So, and then it says we're supposed to use the ratio test and find out when the ratio is less than 1, right? So what I'm going to do is I'm going to add in, I could have done it all the way from the beginning, done a less than 1. Okay. So really what that says is where is the absolute value of x less than 1? But I'm looking for an interval. So to get an interval out of that, remember absolute value means it could have been a positive or a negative. So another way to write this and take the absolute value off is that. So that's my possible interval of convergence, meaning that that series could converge possibly between those two numbers. But we need to check and see if the endpoints converge. So that's the second half of the problem. All right, everybody got that far? Because I got to switch slides. We're good? Okay, so I need to check both of these cases. Okay, and I'm gonna take and plug these numbers in for x and see if that function converges for those numbers. Okay, so I'm gonna start by looking at x equal to -1 and see if it converges for that one. So I'm gonna do the sum as n equals 1 to infinity, and I'm plugging in for the x. I'm plugging that -1 in to the n over the square root of n. All right, whenever we see the negative in there, which one of our series tests, according to your flowchart, are we going to use? Yep, we're going to use alternating. That's the big clue is the negative, right? There are other ones that work for it, but alternating is a kind of our go-to. All right, there were two things we need to check for alternating for convergence. We have to do the limit as what? And approaches infinity of the absolute value of the series, right? I have to check to see and make sure that that equals 0. So if I basically have 1 in the top, right? 1 divided by a giant number is going to equal what? 0. So that the first half of it works. The second thing I need to check for is decreasing terms, right? So to do that, I just start plugging numbers into this. So I plug in a 1, and remember plugging into the absolute value of it. So I'm plugging in a 1, I would get 1 over 1, right? Plug in a 2, I get 1 over square root of 2, 1 over square root of 3, 1 over square root of 4, which is 1/2. What if I put in n equal to 9, I would get 1 over 3. Is it going down?
Yes, ma'am.
Yeah, so it is decreasing. So we know that this one then what? It converges. So I know that that is actually included in the interval of convergence. Okay, so the way we're going to write it, we'll write it out a little bit differently here in a second for our interval. All right, now I've got to test my other endpoint. So I'm going to test x equal to 1. Okay. So I'm putting in n equals 1 to infinity, and I'm putting in a positive 1. What type of series is this?
Geometric.
No.
Oh, it's P.
That's a P series. You can't forget these, okay? Especially the simple ones. Those first 4 you got to know, okay? What's your P equal to? 1/2. So when P is less than 1, does it converge or diverge? Use your chart. Diverges. Okay? So, here's how we're going to write the interval of convergence. All right. I'm going to choose to go, instead of using this notation, which you could use, I'm going to go back to interval notation. Remember interval notation, we use the parentheses and the brackets? It's typically written in that interval notation when you're looking at the answers on the test. Okay, so that's why I'm using that. So if it converges, we use a closed bracket on the interval, so the -1 converges, the 1 diverges, so we go open. You also may see it like this. So both of those are ways to write that. And that's it. This is what they were going for, was the interval of convergence. Okay, we're going to do it one more time. Okay.
Oh, this one was crazy.
I need to show you something on this one. It's not as crazy as it seems. Okay? Alright, what are we supposed to sub in? We're supposed to do ratio test first, so what are we supposed to sub in? N plus 1. And we're subbing in for the n, not the x. Okay? So the limit as n approaches infinity of the absolute value of n plus 1 cubed times x minus 5 to the n plus 1. Now this one, we're not going to have a complex fraction, so I'm just going to go ahead and put the original underneath. So n cubed, or x minus 5 to the n. Alright, let's talk about what could possibly cancel here. These are the same base, right? So doesn't that go away and this whole thing go away? So I'm just left with the x minus 5. So we've got the limit as n approaches infinity. I'm going to go ahead and throw the x minus 5 up front, no particular reason. N plus 1 cubed over n cubed. Alright. Is this limit acting on the x?
No.
No, it's only acting on the n, so I'm going to go ahead and pull that x minus 5 out front and multiply it by the limit that we get here. So we've got an n plus 1. Actually, I'm going to rewrite that a little bit differently. Aren't they both cubed? Yeah, so another way I could write that, I don't have to, would be n plus 1 over n cubed, right? Absolute value there. So my exponent is the same, so what do I use? What's my limit of this thing?
1.
This is 1 again, so aren't I just left with the x minus 5? Alright, and remember, we're supposed to be showing that it is less than 1 to get my interval. Alright, so that's going to change my interval. So the possible interval of convergence that I'm going to get, remember I split this up and I go from -1 to +1. And I need to isolate the x. So what am I going to have to do with that 5? Add it, and I have to add it to both sides of that. So what's -1 plus 5? 4. And what's 1 plus 5? 6. So that's my possible interval of convergence. So now I have to test those endpoints just like I did on the last one. I'm going to go to a different screen to do that. Everybody ready for that or not yet? Okay. I'll wait. Alright, we good now? Okay, so going to the next screen. I'm going to test my 2 endpoints. I'm going to start with the 4. Alright, so that means I take the 4 and I plug it in for the x. Okay? Look at the sum as n equals 1 to infinity of n cubed. If I put 4 into here, what's 4 minus 5? -1 to the n power. I know it's not written in the right order, but if I have a -1, which test am I using? Yep, so let's try an alternating series test. The only reason I write the name down is so we know what we used in our notes. Okay? Alright, so the first thing I have to do is I have to check the limit as n approaches infinity of the absolute value of -1 to the n times n cubed. When I put infinity in there, does it equal 0? No. And I don't care what it equals, I just need to know whether or not it equals 0. It doesn't equal 0, so what does that mean about the alternating series test? It diverges, so it failed. So it diverges. now we're going to do the x equals 6. Okay, so n equals 1 to infinity of n cubed. What's 6 minus 5?
2. No, 1. It's just
1.
like 9.
So really this is just saying the sum is n equals 1 to infinity of n cubed, isn't it?
P series.
It's not a p-series. P-series has to be 1 over something.
Not a P. It's geometric. No, I don't know.
No, it's the, what's the top one?
I don't know.
What's the top one on your flowchart? The nth term test. Okay, so this is an nth term test because there really isn't anything better that it fits in. Okay, so we're just going to simply test the limit as n approaches infinity of n cubed. When I put infinity in there, don't I get infinity? Which is not equal to 0. So according to your chart, what happens? It diverges. So we would have open parentheses on both ends of this interval of convergence. So on this one, the interval of convergence is from 4 to 6 with parentheses, or 4 to 6. Those are inequality symbols. Okay. All right.
Wait, Miss Valerie,
Yes.
why did we put a 1 and a negative 1 on top?
Oh, on that part?
Yeah.
Okay, so when we go to take that absolute value, do we understand that it just has to be less than 1? That's the rule? Okay. So when we break up that absolute value, we have to take it apart. It breaks into positive 1 and negative. Remember algebra 2?
Yeah.
Positive expression and negative expression. That's the concept. Okay?
Oh.
Everybody good? Okay, so the assignment's posted in Haiku. So you can get started on the assignment. If you want to work on the scholarship thing, you could work on that. Okay? Remember, I want everybody to put in for it, because you don't know who I'm even thinking of narrowing it down to picking. Okay? So I honestly don't have anybody even in mind at this point. Okay? Alright? If you want something stamped, you can come see me. Okay? I will be happy to stamp something.